So I'm in the person of Idris Abdul-Ghaffar. You can call me Faraday. And then I'm privileged to be the tutor for this particular playlist, right? Now, there is a function that was given to us to find this particular equation, to solve for this particular differential equation using the method of separation of variable, right? And with the method of separation of variable, our main goal is to be able to get a function of, let's say, g of x dx, a function of x alone, and that of, let's say, f of what? Y dy, right? Realize that we have a function in terms of x and a function in terms of y. After we have established this, the next thing we are going to do is to be able to what? Integrate both sides of the equation, after which we can move on to solve and get our results. And that is basically what we are going to do under this particular questions, right? Okay, so let's move on with it. Now, the function says that solve tan y dx equal what? X dy using the method of separation of variables. How are we going to do this? The best way to do this is to bring the function into its simplest form, right? So realize that the simplest form of what? Tan y is what? Sine y all on what? Cos what? Y dx, right? Which is equal to, and then the that of the cos x is the reciprocal of what? Tan x. Therefore, we can say it's the same as what? Cos x all on what? Sine x dy, right? Now, the next thing, or the easiest way to solve this particular question, is to cross multiply both sides of the equation, right? So that we end up getting sine x sine y, right? Dx equal cos x cos y dy, right? So how are we going to solve this particular question? Realize that we have what? Y function here and that of what? The x function here. So the next thing we'll do is to divide both sides of the equation by what? By cos x, right? And then we do same for the other side of the equation. So this cos x will cancel this particular cos x, right? So we end up getting sine x sine y dx all on what? Cos x, right? And then it will be equal to what? Cos y dy. Realize that we still have sine y in the left side of the equation, right? So we divide here by what? Sine y. And the other side by what? Sine y. Realize that this sine y will cancel this one out, right? So we end up getting a resulting equation, right? In this form. Sine x all on what? Cos x dx, which is equal to cos y all on what? Sine y dy. So realize that we have been able to separate both sides of the equation. That is, we have the x function in the left hand side and that of the y function at the other side. And our main goal was to establish the function in this form where we have g of x dx at the left side and that of the f of what? Y dy at the other side. And that is what we have now. So the next thing we are going to do is to integrate both sides of the equation. So we integrate both sides of the equation plus c. Don't forget to bring your plus c, it's very necessary. Okay. Now we are going to move further to integrate both sides of the equation, okay? And realize that there is a function which states clearly that anytime you have a function such that whenever you differentiate the denominator and you get the numerator, the result is what? Ln of what? The denominator, right? So realize that when we differentiate cos x, we end up getting what? Negative sine x. Realize that that's not actually what we are looking for. Our main goal is that when we differentiate the denominator we'll get the numerator. So we are going to find ways and means to do this by doing something we call, we have done something but then we have done nothing. So we put negative at this side and put negative at the back, such that when you multiply through, you still get the same function. So we've been able to achieve our results. The result will state that anytime you differentiate the denominator and you get the numerator, you should take ln of the denominator as the integral of that particular function. So we have our negative here already. So we have ln of what? Cos x, right? Ln of cos x equal. And then similarly, you realize that if you differentiate sine y, you end up getting cos y. So that means what? The ln of the denominator is that particular what? Function. So we end up getting what? Ln of what? Sine y plus c, right? Now, the next thing we are going to do is to bring the logarithm function to what? One side of the equation. So we are moving the left hand side of the equation to the right hand side. So, and then the c to the other side. So I'll get minus c equal ln of what? Sine y plus ln of what? Cos x, right? So there is a logarithm function which states that anytime we have a log function and then they are adding, you can multiply and take one of the function. So we have ln of what? Sine y multiplying what? Cos what? X, right? So the next thing we are going to do is to what? To take antilog of the function. So, or the exponent of the function, right? So realize that this e exponent will cancel the ln function. And then we end up getting what? Sine y cos x equal e exponent minus c. But any constant is just constant, no matter how the constant looks like. So if we have e exponent minus c, we can say this is the same as what? A. And it's also the same as what? C, right? So we can say what? Cos x sine what? Y is equal to e exponent what? C, sorry, is equal to what? C. I've already established that it's equal to C. And this will be the end of what? Our result.